In this video, I'm going to show you how to get started setting up a geologic model for an alluvial aquifer near Corning, New York. So here's a map of New England, and this shows kind of an overview of some of the superficial geology. The Corning aquifer is right here. And this image and the other images that I'm going to show are from the USGS Groundwater Atlas, and this image is available from this location. You could also find it by searching for USGS Groundwater Atlas Corning Aquifer. So if we look at the superficial, just a map of this is southwestern New York. We can see the Chemung River, the Cohocton River, they come together right here. That's the Tioga River. And the aquifer is right in here. Here's an air photo. This is Corning, New York, right here. The Chemung, and this is the confluence of the Chemung, the Cohocton that comes down here, and the Tioga that comes up there. This is an alluvial valley fill aquifer. So this is the geology, or this is the saturated thickness of the sand and gravel aquifer in these valleys. And I'll show you the scale later. This is not really important, but we're going to focus on this area right here. So I put in these two reference points, and you'll be able to put this model or this image here into your GMS model. And so the locations of these points here and here are shown here for registering this image. So here's an image of the geology, the superficial geology. And again, here are our reference points. And what we see is that at the ground surface, there's some outwash alluvial sand and gravel. And that's the primary aquifer forming material. And then on the periphery of this valley, it's glacial till. And then there are some terraces. These yellow areas are terraces, and the brown is bedrock. Okay, so we're going to want to use this superficial geology along with cross sections shown here. And actually, there's a cross section A prime right there and B prime right here. There's A prime, and here's B prime. And so we want to use the information in the map and the cross section in order to create a geologic model in GMS. So in many cases, if you're creating a geologic model, you'll have borehole data. And if this is a project where you're out doing the drilling, you'll have created the data yourself, or it may be available from some source. But in some cases, such as this one, we don't really have borehole data. And so the whole approach for generating a geologic model in GMS is based on borehole data. So what we need to do is use the data that is available to generate data that would be like what you would have if boreholes were drilled. Okay, so let me explain how that works. If we take this cross section and imagine what would happen if we were to drill holes along these gray lines. These gray lines and the circles with the X's are things that I drew in on top of the cross section that was already given. Also, the cross section here is given in elevation in feet, and the map, the vertical datum that we'll use in GMS is in meters. So on this side, I've got the scale in meters. And so I put in these locations for borings, and I labeled them here. And so what we're going to do is set up a file that has the format that's used by GMS to read in stratigraphic data from boreholes, and we're going to do it by um, interpolating from this cross section. So here's the approach. Um, okay, so I did a little bit more work. I put in some horizontal lines here. And then I put in these red lines, and these are the contacts. Okay. And I had another borehole over here, and I wanted this borehole to be beyond where this till crops out. And so I just estimated what the ground surface was here, but it's pretty steep, so it might be a bit higher than this, but um, that's the ground surface. And then these other places, you can see these red lines, those are the contacts. And then I set up a database here with the information that I'm going to need to have to identify these or set up these boreholes in GMS. So the borehole name is here, and then this is the elevation of the contact, and this is the material that is observed at or below that elevation. So for B1, this 335 is the ground surface. That was the highest point over here, and then this is the bottom of the hole down here, and then B2, the top is 315. I got by just interpolating that. And underneath it is unit 2. And what I've done is gone in and see these numbers here. These are numbers that correspond to the different lithologies that are observed in the cross section. So B2 at 315, that's that contact right there, and underneath it is unit 2. And then here's the contact at 292, and under it is unit 1. And then I said this borehole goes down to an elevation of 260. So it stops right there. And at 260, the unit there at 260 is unit 1. And then borehole 3 is at 287, and it's unit 3, this little terrace gravel. And then there's another contact here at 274, and under that is the till, unit 2. And then here's another contact at 250, and it's unit 1, the bedrock. And then B4 is shown here. This is B4, and these are the elevations. Okay, so that's going to be the data, or some of the data that we use for the boreholes. Okay, so then what I did is, let's see. So these are laid out along a line, and I went back to the map, and here's the cross-section line, and my cross-section goes a little bit further than the cross-section that's shown. So I located the points that will be the boreholes here, and I checked it out. Like that borehole there, that's 1, 2, 3, B3, and you can see how it's hitting the terrace at the surface, and this one is just beyond the stream. So I went and checked, and see this one is hitting the terrace, and then this one is just beyond the stream. So I have the borehole registered properly. Okay, so then I made this image and set it up so I could import it into GMS. Okay, so I set up a GMS model using the online maps. I went to Corning, New York, which is this community right here. And we're looking at the air photo. I also have the NAD, the elevation data set image here. So there it is, with a little bit of transparency. And I also have the geology here with those boring locations. And I put in the saturated thickness map as well. And here are the registration points that I used when I brought those maps in. So the first thing that I needed to do is to set up my borehole database, and I needed the XY locations of my boreholes. So these are the boreholes, and the way that I did this was to create a conceptual model and a coverage that I called points. And here are the points. I only did the first four. There's a few more that still need to be put in, but I put these guys in. And what I did was to, let's go look at the attribute table. So I clicked on show coordinates and I changed the name here. So I named these with the borehole name, and these are the XY locations. So I copied this. And then I set up a Excel spreadsheet and just pasted it here into the spreadsheet. And so I have the borehole name and the XY locations. So I also went to the notes that I made for the locations, or for the stratigraphy, and took these guys and put those over here in the spreadsheet as well. And so then I have the XY locations, and these will be the Z values here and the materials. So the file format is going to be name, X, Y, Z location of the lithologic contact, and then the material underlying that contact, or at or underlying it. And so here's the first one. This location is that location. And you can see I copied it. And then these two locations are from my notes. And B2, this location, and these elevations and materials, 211. Okay, so then I just erase this stuff because I don't really need this. So when I'm done, erase it. Or we could save it, but we would need to erase it at some point because what we're going to do is then save this file. So this is called Corning Borings. So I saved it as a text file. And let's see, that one right there. And what happens then, let's just go ahead and do that. So you can go and bring that in, but you'll see that there's going to be a problem. So there's the text file. And there's the familiar format. We go and have a heading row and select borehole data. But there's a problem. It says an error has occurred in line 15. And so here's what's going on with that. If we go to that file, and just open it with the text, with the notepad, what we see is that there are some blank lines here. When I save the text file in Excel, it creates blank lines. So the program is reading those lines. And it's not like there's nothing. There are actually lines there that are blank. So we have to delete all that stuff. And then I saved it under a new name. I called it Corning Borings with no end space. So that made that's just a tip that there is this problem with the file format that you may run into. So let's go back and delete these boreholes here, and we'll bring in the boreholes that has the no end space. There you go. And okay, so we get no error when we do that. And now we want to go and check the display. I made these boreholes 100 meters wide so I could see them. And borehole names, we might want to make those a bit bigger so we can see those. So here they are. And I also went into the materials and I changed the defaults. It'll be called material 1 or something like that. And so I changed it to use the names that were in the cross sections that I used to get the data from. And I also changed some symbols here and some colors. So now we can take a look at this and see the boreholes here. So that looks pretty good. There's pretty good vertical exaggeration on this. I think if you try it without a vertical exaggeration, there's a 10-to-1 vertical exaggeration. If you try it without the vertical exaggeration, you'll find that there's not really much. It's hard to see much. Okay, so there are the boreholes, and now we want to do the correlations. And if we try to do that automatically, just auto create blank cross sections, it couldn't do it. So that's okay, because we'll just do it ourselves. So we click here, the borehole cross sections, and we just link these up, double click, and that's going to be now our cross section. And here they are. And now we're going to need to fill these in ourselves and do the correlation. So I'm going to select these and then go to borehole cross section editor. Now let's try this. I'm going to right click and go to edit. There we go. Okay, so here are the boreholes, and we can now do the editing or do the correlation. So here's the till, and this is bedrock. So I'm going to say, well, that's what this cross section looks like, and then I can populate it right here. And then I'll switch over to this panel, and here's the till, and there's the contact between the till and the bedrock. So that's going to be a contact there. That'll be a correlation. And then this is the terrace, so that'll go part way up the valley. And we'll try populating that. So there's that cross section. And now we'll go to the next one. And this one's a little tricky. This terrace and the till pinch out, and then this sand here, it extends across, and the sand actually cuts the terrace and the till. So let's see. I'm going to try. If you don't do this in the right order, it doesn't let you complete it the way that you might want to. So I'm going to draw it like this. We might think this is, well, let's just draw it straight up like that. And then this one goes across like this. And so that's going to be the till there and the terrace. And then we've got this. This is the bedrock and the underlying sand. And so that'll go, well, let's take it across like this. No, I think it's going to be like that. And then there's this is a clay lens. So we'll extend that over. And then let's see what that looks like. Okay, so there's that cross section. And there's the cross section that we've developed, the three cross sections put together. And that's coming along. So that's what we've got in GMS now. And if we take a look back at the cross section, it's this end of the cross section here. And so it looks pretty good. So we're on our way to making a geologic model. What we can do is take a look at this, how it looks in with the topography depicted. And of course, though, we're going to want to extend this and include more boreholes, and then also extend it laterally into a three-dimensional solid. So that'll still be work that needs to be done. But let's take a look at this this tin. You can see the contours here, and we'll look at this in plan view. So here are the contours from the tin, and this is the area. You can see the boreholes right here. And you can see the registration looks pretty good where these contours are. And if we look at this in a perspective, you can see that this map, this geologic map, is laid over top of the tin. And the way that that's done is by going here and texture map image to active tin. So you can see over here that the geological map was active. So I'm putting that map over the active tin. If I were to use, for example, the air photo, it would lay the air photo over and over the tin and show it in 3D. So that's kind of a nice effect. And we can see right in here is our data. It's a little bit difficult to see it, so we can try making it, making this the geologic map. We can try making a little transparent, see if that shows it off a little bit better. Okay, so there you can see the topography with the cross section coming in a little bit better here. There are the boreholes, and we can see we want to extend that cross section over. And so this is how you get started taking data from geologic map and cross sections, creating boreholes with in a digital format and bringing it into GMS and doing the correlations in GMS. So you can extend the cross section out along this line here, including these other boreholes, and then you can work on generating the solids by creating horizons and then generating solids from those horizons. So you see what you can get from this one cross section. What you might want to do is put in additional cross sections, and we don't have data from the field, but you can use the data from this cross section to estimate what the elevations of the different units are at the different locations. So try experimenting around and seeing what you can do to generate a three-dimensional geologic model of this region.